Okay, Guy, I think we should start.
All right.
So this is our daily webinar for the Hackorona Hackathon. I guess you missed me. You haven't seen me for a while. Actually, they have seen me this morning. We had the first webinar today was at 11 a.m.
All right.
So anyways, today we have Guy. Guy is with us today, and he's going to talk about really cool developers tips for SQL Server. Right? Am I right?
Yep. Yep. Exactly.
Great. Guy is the CEO for a Madeira company. This is a really cool company. They're doing an amazing job, and and he's also an MVP for Microsoft. And this is really respectful. So, Guy, tell us about you.
All right. So thank you, Idan. Can you see my screen?
No, they cannot. Let me just fix it.
All right. So I would like to share with you some tips for developers when working with SQL Server or Azure SQL Database. And I'm a data platform MVP. Just like Idan said, I'm the CEO of Madeira Data Solutions. We provide solutions and services around the data platform of Microsoft to customers. You can see here my blog, my Twitter handle, and so on. Feel free to keep in touch, ask any questions. I'd love to help. Also, I have lots of demos. I will publish all the demos, all the scripts in my blog later on, so you can access them there. And if you are into SQL Server stuff, I also co-host the SQL Server Radio podcast. So you might want to follow that as well. All right, so I'm going straight to the demo. Everything I'm going to show here is the same for almost the same for Azure SQL Database or Managed Instance or SQL Server on-prem. Specifically here, I'm using SQL Server 2019. I'll tell you where things are different. I want to share some, we only have 30 minutes, it's not much. I want to share some common mistakes that I see developers do all the time when working with SQL database. So let's start. The first thing is working with scalar functions, specifically user-defined scalar functions. I have, as an example, one scalar function here. So this function, something that I wrote, it receives some parameters, performs some business logic. If the status is this and the time difference and whatever, then the result will be very poor, otherwise poor, maybe, and so on and so on. Okay, so these functions check some parameters and outputs a string, which is an invitation rank, whatever. It's a scalar function. Now, it really makes sense to use functions when developing, when programming, right? Because you have some business logic, you want to encapsulate it, you can reuse it in different places. It makes perfect sense. The problem is when you use a scalar function within a relational database, within a SQL query that needs to access millions of rows, you're going to have really issues with big issues with performance. And I want to demonstrate that. So in this case, I have a select statement selecting from this table, invitations, which has, I think, 1 million rows. Okay, not a very big table. And I have here a call to the function. I want to get all the rows that provide excellent as the result of the function. So let me run this. Starts bringing out results. It's going to take some time, I think around 10 seconds or 12 seconds, something like that. And I want to show you a few problems with that. First of all, it takes a lot of time. Okay, I want it to run like 1-2 seconds, maybe top. So it takes like, come on. Okay, still running. The biggest problem with it is, of course, SQL Server has to take each and every row, call the function, run the logic, get back the results. It takes a lot of time, 1 million times. Okay, so it can't execute the query in an efficient way as a set of rows. Okay, it took 34 seconds. Sorry, I probably missed it with something else. The second thing here, if we look at the execution plan, I don't know if you're familiar with looking at execution plans, but I can tell you that this plan is serial. It's using a single thread to execute this query. So only a single thread has to access 1 million rows and perform the function one at a time. And this is because there is a limitation in the SQL engine whenever you use a scalar function in a query, it has to use a single thread. Now, if I will show you later, if I will use something else, not a scalar function, you will suddenly see a parallel plan using multiple threads, multiple cores. It's going to run much, much faster. So that's a second problem. A third problem is that we have issues with memory allocation. SQL Server does not estimate correctly the number of rows that is going to be returned because it doesn't know how many rows are going to be returned from this function. So it doesn't allocate enough memory for the query. Okay, and there are more. Okay, just the beginning. Many issues here. So one thing we can do, if I'm looking for excellent, I can go into the function and look for the specific logic that provides the result excellent. Here it is. Excellent. Okay. So for excellent, I know that I need status 2, and also the day_diff must be lower than 10. So I can do this. I can just put the logic inside the query itself without calling the function. Of course, this means I'm not using a function. I have to put this logic each and every time. I need to modify the query for each and every rank that I want to get. It's not a good performance, a good programming practice. But if I run this, it's going to run for only 2 seconds compared to 34. Okay, it's the same results, same thing. Now, as you can see, you see those yellow circles. This means it's a parallel plan. It uses, in my case, on my laptop, it uses 4 threads, 4 cores to run the query. And it runs much faster because it doesn't have to call the function each and every time. Okay, so this is a huge difference, but it's not good enough because we want to use reuse functions. What we can do in some cases, not always, but in many cases, we can rewrite the scalar function as something called inline function. Okay, so this is another type of function in SQL Server. It gets the same parameters, but it returns a table in this case. And the table, it's a trick I'm doing here. The table is actually a single select statement, which provides a single column and a single row. And the single row is actually one big case expression instead of the multiple if statements we had in the previous function. So it's the same business logic. It does the same, but instead of running a batch of multiple if statements, it now runs a single select statement, resulting with a single result set. And this allows SQL Server to perform an optimization in a much better way. I also need to rewrite my query, unfortunately. Okay, so I'm going to use cross apply to the function. Now it returns another table. It's like another join. And then I'm going to filter on the column that is returned from the function. Okay, so again, I'm doing the same thing logically. I'm still using a function. I'm reusing the business logic. But now performance is very similar to what we did without a function, 2 seconds. Okay, and it runs in parallel and so on and so on. Okay, so we managed to reuse a function and still get very good performance. So the thing you need to remember here is if you care about performance, try to avoid scalar functions as much as you can. Unfortunately, in some cases, you might be able to rewrite them as inline table functions. Sometimes you won't be able. And there is a good thing in SQL Server 2019. There is a new feature, a great feature actually. In many cases, the SQL engine will do the work for you. So even if you use a scalar function like this, without changing anything, by just using SQL Server 2019, the database engine will do the inlining for you. It will rewrite the function as an inline function, just like I did, but it will do it automatically for you behind the scenes, transparent to the application completely, and it will work. But it's not always the case. I'm using SQL Server 2019, for example. It didn't happen. And in this case, it didn't happen because I'm using this function, sysDateTime. So if you're using sysDateTime or getDate, it's not going to work. This is just one limitation. There are all kinds of limitations. But in many other cases, it might work. So that's the first thing. Okay. Avoid scalar functions. Use something else if you can, or rewrite your scalar functions as inline functions for much better performance. Let's move on. The second thing, as you can see, there are many things. I'm not going to show you everything because I only have 30 minutes. I'm going to choose some interesting things, and I'm going to share again all the scripts in my blog. So the second thing I want to talk about is this. Okay, let me empty the plain cache. Now, don't do this in production. This is very dangerous because it's going to clear out all the execution plans from memory. And I'm going to create a store procedure here. And this procedure accepts a parameter date, okay, and has a default value of null. I'm using this read recompile just for the sake of the demo. Okay, so in reality, I'm not going to have this read recompile because I want to show you how it differentiates each time. And what I'm doing here is this. Okay, so this is the thing. The common way that users use this stored procedure, they want to get customers by last purchase date for the last week. This is the common scenario. Okay, so instead of checking the parameter for the last week each and every time, I have a default value of null. And whenever a user executes this stored procedure with null, the user actually means give me the last week. Okay, so inside a stored procedure, I'm saying if it's null, change it to the last week, and then do this select. Give me the customers that the last purchase date is greater than date. Okay, now if date is whatever the user passes here, I'm going to use it here. Otherwise, if it's null, I'm going to change it for the last week. Now this is a common practice. I see it many, many times. Developers do this. It makes sense. Everything is okay, right? Of course not. So let me create an index on the last purchase date, okay, to make it interesting. So let's do this. And now, as the first example, I'm going to run this stored procedure with a specific date, not null. Okay, give me the customer that purchased since 1st of January 2020. And we get around 23,000 rows. Oh, sorry, I want execution plan as well. Let's do it again. Okay, we get a clustered index scan. It's scanning the entire table and doing a predicate on the last purchase date. Okay, this evaluates to 23,000 rows. All right, we're fine with that. Now I'm going to run the stored procedure with null, with a default value of null. And again, I'm going to get customers purchased for in the last week. In this case, it's around 2,000 rows. Okay, and what I want to show you here is if you look here, sorry, I forgot to start zoom it. Oh, I don't have it here. Never mind. Let's do this again. Sorry. If you look here, we see that the estimated number of rows is only 1, while the actual number of rows is 2,000. Okay, and this is a problem. You might not see it because in my demo it runs very fast anyway, but in production, when you have scale, very big tables, this might be a real problem because SQL Server thinks there's only 1 row coming back from this query, okay, in the last week, while in reality there are 2,000, maybe there might be 2 million, I don't know. And it produces an execution plan, in this case an index seek and key lookup, okay, because it thinks it will only have to do the key lookup once. Doing the key lookup 2,000 times is not a good thing, okay, so it's not a good execution plan in this case. Now the reason is, if we go back to the stored procedure, we need to talk about something called parameter sniffing. The way the SQL engine works, it looks at the value of the parameter, okay, here, in this case null. It calls parameter sniffing. It sniffs the value, and during compile time, it will generate an execution plan for this query here based on the value here, okay? So actually at compile time, SQL Server ignores this part. It doesn't really know that it's going to happen at runtime. I'm going to change the value of the parameter later on. So it compiles a plan based on null. Now, how many rows are there where last purchase date is greater than null? 0, or in this case, it assumes 1, only 1. And that's the problem. If I put here 1 year, for example, the problem will be even bigger, okay, because it's still going to think that there is 1 row based on null. In reality, I'm asking for lots of rows, okay, so this is not good. And this is how it works. Again, I see it many, many times. It's a problem, and if you're not aware of it, you don't even know that you have a problem and why there is poor performance. So what we can do, several things. One thing we can do, we can add this option recompile after the query. Now, this is part of the select statements. Okay, it's part of this statement. It's one statement actually. And what it does, option recompile, it instructs SQL Server to recompile this query each and every time, each and every execution. But it does another thing. It recompiles it at runtime. And that's the big difference. Okay, because at runtime, we are here after doing this. So at runtime, SQL Server gets to this point, stops for a second, recompiles this query based on the new value of date last week, and then executes the new plan. Okay, and this solves the problem, of course. Let me show you. If I'm going to do this, and I'm going to run it again with the default value of null. Now we see a different plan, and we see a different plan because now if you look carefully, you see that the estimated number of rows is 2000. It's equal to the actual number of rows. Okay, so the estimate is 100% correct because now it's recompiled at runtime. So actually, option recompile is like magic. Okay, it does really great things for performance. The problem is, of course, if this stop procedure is executed many times per second, it's going to be a real problem because the server is going to have to recompile the query many times per second. It's going to bring your server to its knees. Okay, lots of CPU utilization, not good. So it's dangerous. You have to be careful. But if this stop procedure is executed once in a while, even a few times a minute, it's like nothing, then why not? Go ahead, add option recompile, and it's going to really boost performance because it has all kinds of advantages. One of them is that it happens at runtime. But again, be careful. Another option, if you can't afford to add option recompile because it's executed many times, you can do this. You can add a second stop procedure, an inner stop procedure, okay, which accepts the same parameter without a default value and without the if statement, just execute it. Okay, this is going to be the inner stop procedure. And then I'm going to alter, I'm going to change the original stop procedure, the one that the application is calling. It's going to use the same interface with the null default value, the same if statement, but instead of executing the query right away, it's going to execute the inner stop procedure, passing it the parameter after changing it here. And this inner stop procedure also has the same mechanism of parameter sniffing, but in that case, the parameter is already the value we want it to. So this also solves the problem without having to recompile each and every time. So let me do this. And now, if I run the same execute with the null value, we get the same good plan in this case, with the same good estimation of 2000 without having to recompile each and every time. Okay, so make sure you don't do this. You don't change your parameters values inside, where is it? Sorry, inside the stop procedure. If you have to, then either use option recompile if you can afford it, okay, but be careful. If you can't afford it, then what you can do is create an inner stop procedure, another one. Do whatever you like, make changes to your parameters, whatever you need to do. Once you're ready, instead of doing the select statement right away, call the other stop procedure with the new parameter values. All right, so that was the second thing. Let's move on to, where are we? Optimize search arguments. Okay. So this is kind of basic, but some developers without experience in working with SQL might miss it. Let's do this again. I have a query here with some joins and some filters in the where clause. Okay. In this case, I want to get all the members and all the member sessions, and I want only the sessions that happen on a specific date. In this case, February 15, 2020. Okay. So I use the functions year, month, and day. Okay, that's very easy. I can say something like this. If I do this, okay, if I do this, it's not the same as doing this. Okay, because in my table, login datetime is a datetime, actually datetime 2 data type, and I have all kinds of rows with different times inside the February 15th day. Okay, and if I do this, this is just like saying midnight. Okay, sorry, this. Okay, and there are probably no rows, or maybe by accident there is one row at midnight, but I'm not going to get all the rows during the day. So this is not the way to do it. If I run the functions year, month, and day, of course I get all the rows inside the day. So let me run this. So we get 2,600 rows, something like that. And if you look at the plan, what I want to show you here is this. We have a clustered index scan on the member sessions table. And in this predicate here, this long text, it's actually the filters we have in the where clause. So it's scanning the entire table, checking each and every row for the three functions, year, month, and day, whether it's true or false, and decides whether to fetch the row or not. The problem is we have an index on the login datetime, but it's not using it. Okay, so instead of scanning, I don't know how many million rows we have in the table, I expect SQL Server to use the index to perform an index seek and only fetch the 2,000 rows we need. It doesn't do that. And the reason it doesn't do that because of those functions. As soon as you have any type of function, any type of calculation over a column, even though you have an index on that column, SQL Server cannot use the column. It has to do a complete entire scan of the entire table. Okay, and of course this is not good. So what we need to do, we need to somehow add a filter in the where clause that only filters on the specific column without any functions around it. Another way we can do it, I see some developers do something like this. Okay, if I want to get all the rows in a specific date, then I can do daydiff, give me the number of days between some value, some date, whatever, at midnight, okay, and the current row, the login date time in the current row. Now, because I'm doing the daydiff in full days, I'm going to eliminate the time part. Okay, I'm going to check to get an integer of the number of days. Then I'm going to add this integer back, date add back to the same date, and I'm saying the result date has to be this. Okay, at midnight exactly. So it's another way to get the same result. And in this case, SQL Server now does a different plan. Okay, instead of clustered index scan, it's using an index scan. It's a different index because the estimation is different, but it's still a scan. It's not a seek. It's still scanning the entire table. Okay, the reason is because of this new predicate here, because of this complicated expression, SQL Server says, I think there are going to be one row, 1.01587 rows coming from this query, when in reality there are 2,500, 2,600 rows more or less, okay? Whereas in the previous query, for example, based on those three functions, still have the same actual number of rows, but the estimated number of rows is now 8,000 more or less, okay? Completely different number. Both of them are inaccurate, okay? Because we're using functions, SQL Server is not good at estimating how many rows will come out of those functions. So another way to do it is by using cast, okay? So cast the date time value that we have in the table, cast each and every value to date, only date, and make it check if it's equal to this, okay, this date. So in this case, we do get an index seek, okay, which is a great thing. So Microsoft did some optimization here, even though this is just it's a function, it's a type of function, just like any other function. So we're still doing a function on the column. But in this case, we have a specific optimization where SQL Server can still do an index seek on our column, but we still have a problem with estimating the number of rows. If you can look here, you see that the estimated number of rows is still 1, which is very inaccurate because the actual number of rows, again, is 2,600. Okay, so it's not good enough. And this is why the plan is still not the optimal plan in this case. And the best way, the correct way to do it is this. Okay, so this is the right way to do it. If I want all the rows in a specific date, then we do it like this. Now, here we have no function whatsoever. Okay, I'm just filtering on the column itself. So give me all the rows where login date time is greater or equal to February 15 at midnight and smaller than February 16 at midnight. Okay, again, the same results, but now we have the best optimal plan. We get, in this case, we don't get an index seek, but this is on purpose, okay? Because now SQL Server says, I know, look at this number of rows. I know there are going to be 2,700, so it's not 100% accurate, but it's very, very close. And for this number of rows, I prefer to do a scan rather than a seek and many, many key lookups, okay? So that's the way to do it. Make sure that you write your predicates, your filters in the where clause in this way. On the left-hand side, only the name of the column. On the right-hand side, whatever you like. Okay, do some calculations, constants, parameters, whatever. But make sure that you don't have any calculations or functions in the left-hand side of your where clause filters. Okay, and I think I have time for another one. And this will be table variables. Here it is. The problem with table variables. Okay, so as you might know, in SQL Server, or again, Azure SQL Database, we have two types of temporary tables. We have a table variable, like I'm using here. I have a stop procedure, declare at, in this case, potential couples, table, and then the table itself, insert some rows into the table variable. Then I insert to some other table, selecting from my table variable and joining it to something else, and so on and so on. So this is a table variable. Okay. The other option is to use a temporary table. Okay, and I'm going to show you the temporary table in a second, and I want to talk about the differences between them. There are many differences. Okay, you have a complete session just about this topic, but the biggest difference between table variables and temporary tables is statistics. We have statistics in temporary tables. Statistics meaning we have a histogram. SQL Server can estimate based on the histogram the number of rows for each and every query against the temporary table. While with table variables, we don't have statistics. So SQL Server doesn't have a clue about the number of rows in the table variable. And this is a big problem. Now, before I go into the demo, there is a new feature, again, a great feature in SQL Server 2019, and in this case also in Azure SQL Database, which is called deferred compilation for table variables. So only in the first execution, when SQL Server has to generate an execution plan, it will wait until runtime and then compile the plan based on the actual number of rows of the table variable. Okay, so this is a great feature, but I want to show you, let's say that you're using an older version of SQL Server. Let's put it off to show you how it behaves without this new feature. So I'm going to run, sorry, I think this was the one with 12 seconds duration, something like that. I thought it was the other one. I'm going to run this, and it's using table variables without deferred compilation. And I want to show you, oh, I think I didn't put the execution plan on. Yeah, sorry. I'm going to do it again. So it was like 30 seconds, right? Something like that. And I'm going to show you the estimated number of rows for the table variable. Okay, so it's always going to be 1, and that's a big problem. Even if you have a billion rows inside a table variable, SQL Server will always estimate 1 row because there are no statistics. It doesn't have a clue. Let me show you. If we go here, we have this table scan from the table variable. So the actual number of rows is 176410. You see that number, and the estimated number of rows is only 1. Okay, and because of that, we get a very poor plan that runs for 16 seconds in this case. Okay, the way to do it in previous versions is simply to replace the table variable with a temporary table like this. Create table instead of declare, and it looks now like this: potential couples, the number sign instead of the @ sign. Everything else is the same. I also need to add a drop table at the end. Okay, so it's the same step procedure, only replaced declare table with create table and @ with number sign. But now we have statistics. So instead of 16 seconds, it runs for 3 seconds. Okay, and now if we go here, we have the same table scan operator, only on the number side, the temporary table, sorry. Okay, and if you look at the estimated number of rows, it's now exactly the same as the actual number of rows, and because of that, we get a much better plan. As you can see, this is a parallel plan. Before we had a serial plan, and many other issues that we had before. So this is much better. And the nice thing is, again, if we turn it on, which is the default in Azure SQL Database and in SQL Server 2019, then now even if we go back to the table variable option and we run this, for the table variable, we still get, in this case, 4 seconds. Okay, and we get the correct number of rows, the estimated number of rows, but it only works for the first time with table variables. Okay, this deferred compilation feature only works for the first time. So for the first execution, it's okay. Now, if the number of rows in the table variable is going to change significantly between executions, you're still going to have a problem. So it's not going to estimate 1 row, but it's going to estimate the same number of rows as in the first execution each and every time, which might be so much different for the actual value. With temporary tables, you get much better results because it recompiles the plan based on the number of rows whenever it changes. Okay, so you get much better performance. So let me try to summarize some of the tips I provided here. So the first one: avoid using scalar functions in SQL Server or Azure SQL Database. If you have to, or if you want to, you can try and rewrite your scalar functions as inline functions. that's similar to what I show you here. Or if you're using SQL Server 2019, in many cases, SQL Server will do it for you, which is a great feature. Second thing is if you use a store procedure or actually any query with parameters, which uses parameters, don't change the parameter values inside the store procedure or inside a batch, okay? Because SQL Server uses parameter sniffing, and the execution plan is going to be based on the first value, not after you change it, okay? If you have to change it, do whatever you need to do, then use either option recompile or call an in or a second store procedure with a new value, all right? Third thing, make sure that you use in your workloads, use filters only on column names without any functions so that you can use statistics correctly and indexes correctly. And the last thing, what I show you right here, always prefer to use temporary tables over table variables. There are some really edge cases where table variables might perform better than temporary table, but they are really, really edge cases. So in 99% of the cases, prefer temporary tables. And again, there's a new feature in 2019 in Azure SQL Database of deferred compilation. At least the first execution with table variables will be okay, will be fine. That's it. Again, I'm going to share everything on my blog, okay? So you can check it out later. If you have any questions, try me on Twitter or Facebook or whatever, and I'll be happy to help. Thank you very much.
Thank you, Guy. Thank you very much. Actually, this is obvious that you have a lot of knowledge about SQL. So actually, you shared so much information, and in 30 minutes, a little bit more than 30 minutes, it's insane. So
Yeah,
thank you.
as you can see, I have a lot more, so it's just the beginning.
No doubt that you're an MVP. It's an easy decision. Anyways, so I think this is actually our last webinar for this week. The next webinar is going to be on Monday, and it's going to be very cool. The next webinar will be delivered by Jeffrey Dahan. His webinar is going to talk about from ideation to production, how you create an idea and actually execute it. So stay tuned. It's going to be very, very interesting. I encourage you to join us for the next webinar on Monday, the same time, the same place. We're going to be here. I'm going to be here. So I look forward to seeing you next week. Thank you very much, Guy.
Thank you.
Bye.
Bye.